Was it? It was pretty long. Okay, so I did the whole first page. I got all the way here. I did not do example 2. Okay, so we got to do example 2. Okay. So here we got to find the transformations and the locator point and then graph the function. So what are the transformations for example 2? Compression. Okay, compression of 1/2. Okay, vertical compression of 1/2. What else? Right 1. Up 5. Does the little exponent of 3 do anything? What does the little exponent of 3 tell you? Yeah, it tells you that it's a cubic. So the little 3 is not a transformation. The little 3 tells you which parent graph it is. So it tells you that you're talking about a cubic function, not a parabola, not an absolute value, not a square root, not a cube root. It tells you which graph you're looking at, like what the general shape of the graph is. Okay, the locator point is what? 1, 5. Okay, and then if we're going to graph the function, we need to have the points. And what are the points for a cubic? That's for cube root, or square root. Square root doesn't have any negatives. So we plug in -2 and we get -8. We plug in -1, we get -1. Plug in 0, get 0. Plug in 1, get 1. Plug in 2 and we get 8. Later this period, I'll write them all on the board so that we have them all just sitting there. Okay, so how do we do a vertical compression? Multiply by 1/2. So we're going to take the y coordinate and cut it in half. Okay, so I did that. And how do we go to the right 5? Wait, did I say right 5? I meant right 1. How do we go to the right 1? Add 1 to the x. Add 1, okay. And then how do we go up 5? Add 5 to the y. Okay, so we have -1, -1. 0, 4.5, 1, 5, 2, 5.5, and 3, 9. And the way these graphs always look when you graph them is this further? This is further apart than that is? Did I do my math bad? 4 plus 5 is 9. -4 plus 5 is 1. Oh, positive 1. I graphed it bad. There we go. Okay. When you graph these, if you start at the middle, it's half a parabola going up, so like half of a U going up, and then half of a U going down. So I always start at the middle when I graph these. Somebody want to answer that and say, okay. All right, so, and then I did the cube root parent function, and then we have to do this example, okay? Find the transformations and the locator point. Okay, so what are the transformations? Okay, vertically stretched by 4. Okay, what else? Right. 6, okay. Up 2. Okay, locator point is 6, 2. Okay. And then the table for this one is kind of weird, right? What's the table for this one? Nah, that's the square root one. So this one should be right above. I don't have it filled out because I didn't do the video. Yeah, so it's just the flipped version of the one we did last. So -8, -2, and then -1, -1. So how, can somebody remind me, how did I come up with these values? Why didn't I do -2 to 2? Yeah, I was picking numbers that were perfect cubes. So 0 you can cube root, -1 you can cube root, -2 you can't cube root, well you can, but it's a decimal. -3, -4, -5, -6, -7, none of those cube root nicely. -8 is the next number that is a nice cube root. So that's why we did these numbers instead of -2 to 2. Okay. All right, so how do I do a vertical stretch of 4? Okay, multiply by 4. Which coordinate? The y? Okay, so we're going to do -8, -8, -1, -4, 0, 0, 1, 4, 8, 8. Okay. Aside from the fact that we now have so many different tables, are you guys okay with doing the transformations to the points? That's making sense? Okay. How do we do to the right 6? Okay, add 6 to the x. Well, some of these points aren't going to fit on the graph. Okay. Just one. And then how do we move up 2? Okay. Add 2. All right. So -2. -6, 5, -2, 6, +2, 7, +6, and then 1, 2, 3, 4, 14, 10. I went ahead and I graphed 14, 10 anyway. Does everyone see it's right up here? Just off the graph. And so with a cube root, we still have the parabola, like half a parabola one way and half a parabola the other way. They're just sideways. So I'm going to say it's like half of the U shape like this. There's half my U. And then here's the other half of the U. And for whatever reason, you can kind of see it right here actually, but people call the cubic curves, they call them S-curves. You can see it here a little bit. On example 2, you can't really see it, but here you can kind of see why they would call it an S-curve. Okay, are we comfortable with those examples? Yes? Okay, well, let's flip the page. All right, which ones did I skip on this one? I did all of these? What a... Really? I did the whole rest of the packet? What a boring video. Oh, man. What a terrible weekend video. Man, okay. And how are our brains feeling about it? Brains are like,
It wasn't, yeah, it was like, it was like, I guess this is the 40 days. I was just writing stuff down, so I had to like stop.
yeah. It was more like tedious than anything. It was like, okay, we get it, we've done it, we know it. Okay. All right, so when you look at this